Splitting an atom is easy. Building a bomb is impossible. You need an invisible city. You need 130,000 people. You consume 10% of a nation's electricity just to fill a coffee cup. If you fail, the Nazis win the world. This is the Manhattan Project, an equation transformed into an apocalypse.
How do you engineer the end of the world? Subscribe to Method and Myth as we deconstruct the physics of annihilation.
In 1939, just before the outbreak of World War II, Albert Einstein signed a letter to US President Franklin D. Roosevelt. The letter contained a terrifying warning. German scientists had discovered nuclear fission. They knew how to split the uranium atom. When a heavy atom splits, it releases a microscopic burst of energy. But if you can make that splitting atom hit another atom, and another, and another, you create a self-sustaining chain reaction. The result is a release of energy so massive it defies human comprehension. Roosevelt authorized a top-secret response. The United States military partnered with the greatest physicists on Earth, led by J. Robert Oppenheimer. History remembers the Manhattan Project as a triumph of theoretical physics, but the theory was the easy part. The Manhattan Project was not a science experiment. It was a brutal, brute force industrial engineering operation. It was a race against time and mechanics. Because to build a uranium bomb, you need a very specific type of uranium, and the Earth does not want to give it to you. Natural uranium mined from the ground is 99.3% uranium-238. It is utterly useless for a bomb. To create a nuclear explosion, you need a rare isotope called uranium-235. It makes up only 0.7% of the ore. The engineering problem was nightmarish. U-238 and U-235 are chemically identical. You cannot separate them with acid, fire, or chemical reactions. The only difference is that U-235 is slightly lighter, less than 1% lighter. Separating them is like taking a beach made of millions of grains of sand and being told to find the few grains that are a fraction of a milligram lighter, using only your hands. To solve this, the United States government bought 60,000 acres of farmland in Tennessee. They built Oak Ridge, a secret city that did not exist on any map. It housed 75,000 workers. The perimeter was guarded by barbed wire and machine guns. And inside this city, they built the Y-12 plant to house machines called calutrons. A calutron is a giant mass spectrometer. It turns uranium into a gas, shoots it through a massive electromagnet, and bends the beam. Because U-235 is slightly lighter, it bends just a tiny bit tighter than the heavier U-238. You literally separate the atoms using pure magnetic force. But to build electromagnets this powerful, they needed massive amounts of copper wire. It was 1943. Copper was urgently needed for bullets, tanks, and ships. There was no copper left in America. So, project engineers went to the US Treasury and asked for silver. The Treasury handed over 14,000 tons of solid silver bullion. They melted down the nation's wealth, pulled it into wire, and built the magnets. Tens of thousands of young women, known as the Calutron Girls, operated these massive machines 24 hours a day. They adjusted dials to keep the meters balanced. They had no idea they were separating uranium. They didn't know they were building a bomb. They were just turning dials. It took an entire city, consuming 10% of the nation's electrical grid for 2 years, to produce just 140 pounds of weapons-grade uranium-235, enough for exactly one bomb, the Little Boy design. It was a simple gun-type weapon. You fire one piece of uranium into another, and it explodes. But while Oak Ridge was slowly separating uranium, scientists at another secret facility, Los Alamos, New Mexico, were building a second bomb out of a man-made element, plutonium, the Fat Man bomb. Plutonium was easier to produce in nuclear reactors, but it had a fatal engineering flaw. It was too reactive. If you tried to shoot two pieces of plutonium together in a gun design, they would melt and blow themselves apart before a full nuclear explosion could happen. It would fizzle out. You couldn't shoot it, you had to squeeze it. The Los Alamos engineers had to design an implosion weapon. You take a solid sphere of plutonium, surround it with conventional explosives, and detonate them all at the exact same microsecond. The shockwaves travel inward, crushing the solid metal core, increasing its density until it goes supercritical. But physics hates perfect spheres. If you just drop explosives around a ball and detonate them, the shockwaves are chaotic. The core will squirt out the sides like squeezing a wet bar of soap. To fix this, they invented explosive lenses. Just like a glass lens focuses light to a single point, they combined fast-burning and slow-burning explosives in precise mathematical geometries. When detonated, these lenses shaped the blast wave, bending it, forcing the shockwave to hit the plutonium core with absolute, flawless symmetry from all sides, compressing solid metal into a fraction of its size. On July 16, 1945, at 5:29 a.m., in the desert of Alamogordo, New Mexico, the implosion method was tested, the Trinity test. The explosive lenses fired. The plutonium was crushed. The atoms split. For a fraction of a second, the temperature at the center of the blast was 4 times hotter than the center of the sun. A massive, terrifying mushroom cloud rose 38,000 feet into the air. J. Robert Oppenheimer watched the fire consume the sky and recalled a line from Hindu scripture, "Now I am become death, the destroyer of worlds." The engineering was perfect. Humanity had successfully built a machine capable of ending itself. The atomic bomb ended the war, but the knowledge of how to build it couldn't be erased. It plunged the world into a Cold War of nuclear deterrence. Next time on Method and Myth, we deconstruct the terrifying mathematics of mutually assured destruction and the intercontinental ballistic missiles built to deliver the fire.